everyone, welcome back to CFI Helper. Today we're going to be covering how to do a weight and balance. Now this is pretty important. It's going to be used a lot throughout your flight training. Any written exams, even your flight tests, you're going to need to know how to do a weight and balance. So let's get started. What you see on the left here, I'm going to be using the 172 POH for our example here, but any plane you're using, you can literally pull out the POH for that plane and find something pretty much identical to this. And I pulled this out from section 6, which is the weight and balance section. And we're going to be using the basic empty weight, which is 1,642. The basic empty weight, you'll be able to find this in the documents that you are going to be checking for your plane before your flight. But for our sake, for this example, we're just going to use what we have here, which is 1642, okay? Now, I also wrote the C of G here just because I want you to know how to find the arm given the weight and the moment. It's pretty important and it's going to be used a lot throughout your weight and balance. So let's just go through this really quickly. We know that our weight is 1642, okay? And we know our formula here that weight times arm equals moment, okay? But in order to find the arm, we need to rearrange that equation. So in that case, we know that the arm would be equal to the moment divided by the weight. So because of that, our moment is 62.6, but this is divided by 1,000. So you need to multiply that by 1,000. Because of that, you're going to get 62,600. And then you're going to divide that by the weight, which is 1642. Now, when I did that, I get 38.1. Okay, and we're going to be using this a lot throughout what we do in this video, which is why I just wanted to show this really quickly here. But now we have this information, okay? So how I like to do my weight and balances here is I like to use this, but I like to draw the different sections. So I draw the weight, I draw the arm, and I draw the moment here. Okay, so let's start with what we know. Okay, we know that for the weight of our plane, it's 1642. We know that our arm is 38.1, and we know that the moment, I guess, let me write divided by 1,000 here, just to keep it simple, is 62.6, okay? The next step here is we're going to go on to fuel. The example that we have up here, we know that we need 40 gallons of fuel, but we need the weight in pounds, right? We're not going to put 40 here because you're not going to put the gallons to add up the weight. We need how many pounds is 40 gallons of fuel. And so because in our 172, we're just using avgas, we can multiply that by 6. We can multiply 40 by 6. So if you multiply 40 by 6, you're going to find that the weight of your fuel is 240 pounds. So I'm going to write that down here. Now, our next thing, we need to find out the arm. We need to find out what the arm is so that we can find the moment, right? Let me show you something here. So these are two more pages I pulled from the POH. There's two ways you can figure this out. I prefer just using the loading arrangements page, but I wanted to show you the other one just in case that's something that you would prefer to use. So for the loading arrangements, as you can see here, the usable fuel center of gravity arm for integral tanks is located at station 48. So that's what I'm going to use, okay? I'm going to put that here. So I know that my arm is 48. Okay? So we have the weight, we multiply it by the arm, and in this case, when we do that, we'll get 11,520. But again, we're dividing that by 1,000, right? So we'll get 11.5. So the other way I wanted to show you here, remember 11.5, is you can use this loading graph. So this is the weight, and you can use this for multiple things in the weight and balance. You can use it for the weight of the passengers, the weight of the fuel, the weight of the rear passengers, baggage area 1, and baggage area 2. And this will help you find the moment, but just by using the graph. So if you really don't feel like doing weight times arm equals moment, you can definitely use this. Now, using the 240 pounds of fuel we had, I just want to show you how this would work. So for example, this is 240 pounds here. I just put the line. And you would bring it to the right, and then we stop once we reach the line for fuel, right? Then we bring that all the way down, and we find that it's at about 11, and then it's almost at 12. So again, it's close to 11.5. Now, just because I have trouble gauging the number, I prefer to use the loading arrangements page here. Okay, so let's move on to our next piece of information. We have the weight of the front passengers, which is 300 pounds. So let's write this in here. Okay, we have 300 pounds. And then again, let's go back to this page. So for the front passengers, it's going to be this section right here. You can see that it says 37 is going to be the arm. And underneath that, it says 34 to 46. Now, 37 is just the average. If you had your seats pulled all the way to the front, you could use 34. But for the sake of this question, just to average it out, we're just going to use 37, okay? So our arm is going to be 37. And when you multiply the weight by the arm, you're going to get 11,000. It's like 11,100, somewhere around there. But again, we're just going to divide by 1,000, so 11.1. Now we just need to go for the rear passengers, right? So we have 80 pounds. And then we're going to go back. We see that for the rear passengers, the arm is 73. So let's write that down here. And then 80 times 73 divided by 1,000, right? You're going to get 5.8. And finally, our last piece of information is the baggage area. We have 20 pounds in that compartment. But this is baggage area 1. So we want to take the arm here, not the arm here, right? Because this is baggage area 2. So we know that baggage area 1 has an arm of 95. So we'll write down our weight again, right? 20 pounds. And we know that the arm is 95. And then when we multiply those two and divide by 1,000, you'll get 1.9. Now, what you'll notice here is we've reached the end of these first 6 steps. Now, the 7th step is to find your ramp weight and moment. So when we add this up, this is going to be our ramp weight. After adding up all of the weights and the basic empty weight, this is how much we are going to weigh on the ramp before we've done our startup, taxi, run up, like taxi to the runway, that sort of thing. So let's calculate that really quickly. When I add up all these numbers, I get, let me put this in a different color actually, so it's a little more visible. I get 2,282. And then if you don't add up the arms here, because those are just set numbers, right? But you do add up the moment because this is something you calculated. So here we are going to get 92.9. And then what you see here is subtracting 8 pounds and 0.4 for the moment. And if you divide 8 by 6, you'll find that this is just telling you you're losing about a gallon for start, taxi, and run up. So they're just trying to take that off of the weight and balance so you can see how much you weigh for takeoff. So let's do that too. Okay, so we'll copy that. You can just copy it because this is literally from the POH of the 172 and you're flying the 172. So the number is most likely going to be the same. And then we just want to subtract 0.4 from here. So now we can find our takeoff weight and moment. So that's going to be 2,274. And then when you subtract 0.4 here, you're going to get 92.5. Okay, perfect. So we have our moment, we have our weight. I'm going to show you 2 graphs to determine whether we're in limits. And in order for you to use both of those graphs, you also need to know the arm here. So how we find the arm is we divide the moment by the weight, right? So this would be 92,500, the 92.5, and you would divide that by 2,274. And when you do that, you're going to get 40.1. So that's our arm. So we have the weight of the plane. We've solved the first part of this question. We know that for this weight and balance, the weight of our plane is 2,274 pounds. Now let's determine if it's in limits. So just to make this easier, maybe I'll just write the weight of our plane up here. Okay, so 2,274. The arm is 40.1. And then the moment is 92.5. Okay? And just for time's sake, I did draw the lines out, but I'll just walk you through it really quickly. So this one here on our left uses the loaded airplane weight, which you can see here on the y-axis, and then it uses the loaded airplane moment. So the loaded airplane weight, we know that it's going to weigh 2,274 pounds. So this is 2,200 here. Over here would probably be 2,250. And so I gauge that 2,274 is right around here. So I draw a line horizontally like this, okay? And then it also uses the loaded airplane moment, and we know that the moment is 92.5. So using the very small lines that we have here, I found 92.5 and I draw that line straight up. And this blue dot here is where we are. Where these two lines intersect is where you will find yourself. And as you can see, we want to be in this black box, and we are, so we're within limits. Now, we're in the normal category. We're not in the utility category. So what this is telling us is we can't do like spins, okay? We could do some upper air work, going across country, but we can't do spins. But that's fine, we're still in the normal category. Our plane is within limits. Now, if we use this example here, also taken from the weight and balance section of the POH, this uses the loaded airplane weight again, but this time it uses the airplane CFG location. So that's why I calculated the arm. Sorry, did not mean to draw that blue line there. But that's why I calculated the arm, because now you can use this one too if you wanted to. So once again, I found 2,274, which is right around here, and I drew a line across. And then our arm was 40.1. So just down here, and I drew a line up. And once again, where this intersects is where we are. So again, as you can see, we are in limits. We're not in the utility category, but we're in the normal category, and we are within center of gravity limits. We are inside this box. So to answer this question, the weight of our plane is 2,274, and we are indeed within limits, okay? I hope that helped, and I hope that explained anything that you may have been unsure of before hopping onto this video. This sort of question can come up a lot in your writtens and your flight tests, and even just day-to-day flying, so it's really important to know how to complete a weight and balance, and I hope that you learned something from this video. Thanks for watching, and I'll see you in the next one.